Assalamualaikum warahmatullahi taala wabarakatuh. My name is Shakil Adib bin Muhammad Nazri, and this is my group members. Represent Nur Haikal Rakimi Nur Hisham, Muhammad Jad Shakir bin Muhammad Fakhruddin, Amsyah Husairi bin Ahmad Rushdi, Muhammad Anik Aizat Najmi bin Muhammad Qasim, and me, Shakil Adib bin Muhammad Nazri. For this project, simulating intermediate building blocks, we choose 2 to 4 decoder with enable and 4-bit register with load and clear.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Anik Aizat Najmi bin Muhammad Qasim. Number metri 088328. And I will explain briefly about the introduction for 2 to 4 decoder with enable. And first is a 2 to 4 decoder is a type of combinational logic circuit, which is it takes a 2 binary input, and based on the input it activates one of 4 unique output lines, and then it used to decode binary data into a specific output, and it often includes an enable input which control whether the decoder is active or disabled. And it commonly used in memory addressing, control circuit, and digital system. Okay, for the 4-bit register with load and clear, first is a 4-bit register is a digital device, a digital storage device, which is it can store 4 bits data at the same time. Second, it keeps the stored data until it is changed, meaning the value inside stays the same on every clock pass unless load and clear is used. Then the load input allow new data to be stored, meaning when load is active, the register takes the input bits and update its value. Next, the clear input. The clear input resets the register until to 0. When clear is active, all bits are set to 0 immediately. And lastly, commonly used in counter processor and memory units, meaning the register is used in counter processor and memory units to help hold temporary data while the system is working. Okay, for the simulation design of the 2 to 4 decoder we enable, it has inputs, gates, and control signals. And the first one is inputs. A0, A1, 2 bits input that select one of 4 outputs, meaning these are the 2-bit input lines that determine which one of the 4 outputs will be selected. Then enable activates the decoder when enable is 0. All outputs stay low, meaning a control input that turns the decoder on. When enable 0, every output remains low, regardless of A0 and A1. And for the gates, 2 NOT gates produce A0 and A1, meaning it used to produce the inverted versions of the input signal, which is A0 and A1. And for the 4 AND gates, generate outputs Y0, Y3 based on A1, A0 and enable, meaning each AND gate generates Y0, Y3 based on the specific combination of A1, A0 and the enable signal. And lastly, for the control signal, enable main control. When enable is 1, decoder works. When enable is 0, outputs off. Meaning serve as the main activation signal. The decoder only works when enable is 1. If enable is 0, all outputs are low, which mean off. And lastly, A1, A0. Choose which outputs becomes high. This binary inputs decide which single output line Y0, Y3 will be set high.
Next, simulation design for 4-bit register with load and clear. The 4-bit register is built using 4 data inputs, D0 to D3, which provide the parallel data, along with a clock signal that controls when the value is stored, and a load signal that determines whether the register should accept new data or keep the previous data. The design used 4 D flip-flops, one for each bit, with internal wiring that manage the load, function, and feedback path. The operation is controlled by 3 main signals: load, which enables writing new data; clear, which instantly reset the outputs to 0; and the clock, which synchronizes all updates on the rising edge.
Assalamualaikum, my name is Amshau Seri bin Ahmad Rushdi. My metric number 087837. Hello and good day everyone. Today I will explain how to design a 2 to 4 decoder we enable active high using LogiSIM evolution version. This process involves 3 main parts. First, how to calculate and fill in the truth table. Second, how to draw the logic diagram. And third, how to build and simulate the circuit step by step in LogiSIM evolution. Part 1, truth table. The first step is to identify the inputs and outputs. For a 2 to 4 decoder, we have 3 inputs: enable, A1, A0, and 4 outputs: Y0, Y1, Y2, and Y3. When enable equal to 0, all outputs are 0. When enable equal to 1, only one output becomes 1 depending on the binary combination of A1 and A0. For example, if A1 equal to 0 and A0 equal to 0, Y0 equal to 1. If A1 equal to 0 and A0 equal to 1, Y1 equal to 1. If A1 equal to 1 and A0 equal to 0, Y2 equal to 1. And if A1 equal to 1 and A0 equal to 1, Y3 equal to 1. That's how we complete the truth table of the decoder. Part 2, logic diagram. Based on the truth table, we can write the logic equation. Y0 equal to enable A1, A0. Y1 enable A1, A0. Y2 enable A1, A0. Y3 enable A1, A0. From this equation, we can draw the logic diagram using AND and NOT gates. 2 NOT gates are used to invert A1 and A0, and for 3 inputs and gates generate Y0 through Y3. Part 3, LogiSIM simulation. Now let's put the circuit in LogiSIM evolution. Step 1, place 3 input pins and label them enable, A1 and A0. Step 2, add 2 NOT gates and connect them to A1 and A0. Step 3, add 3 inputs and gates and connect them according to the logic equation. Step 4, place 4 output pin label Y0, Y1, Y2 and Y3. Then connect them to each AND gate output. Finally, run the simulation. When enable equal to 1, only one output becomes high depending on the input combination. When enable equal to 0, all outputs remains low. This confirms that the decoder circuits work correctly. In conclusion, we have successfully built the simulate a 2 to 4 decoder with enable using LogiSIM evolution. This type of decoder is commonly used in memory selection and control signal circuits in computer system.
For the Boolean table, the formula is F equal to D0 and D1 or D2 and D3. So the basic formula is the row and the let is 2 power of 4 is equal to 16 line and 4 row. So just insert the value of D1 until D3 based on binary number. For example, in line 3, the formula will be 0 and 0 or 1 and 0 equal to 0. Then in line 4, the formula will be 0 and 0 or 1 and 1 equal to 1.
Okay, next for the screenshots of LogiSIM circuit. For the 2 to 4 decoder we enable. The first picture is showing that if enable is 0, all outputs become 0. For the second picture, showing that if enable is 1, output Y0 equal to 1, another output is 0. And for the third picture, when A0 equal to 0, 0, only Y0 equal to 1, others become 0. Okay, for the next picture is when A1 A0 equal to 0, 1, only Y1 equal to 1, other outputs are 0. Next, when A1 A0 equal to 1, 0, only Y2 equal to 1, others output is 0. And lastly, when A1 A0 equal to 1, 1, only Y3 equal to 1, output will be 0.
Assalamualaikum warahmatullahi wabarakatuh. My name Muhammad Jet Shakir bin Muhammad Fakhruddin. My matric number is 087035. So today I will continue to explain about explanation of circuit functionality. So the first picture, all input are set to 0. If T30 equal to 0, load equal 0, clear equal 0 and clock equal to 0, all output will be 0. As a result, all the output Q3, Q2, Q1 and Q0 remain at 0. Okay, for the second picture, if D3 equal to 1, load equal to 1, log equal to 1, clear equal to 0, Q3 equal to 1. As a result, Q3 become 1 while Q2, Q1 and Q0 remain 0. Okay, for the third picture, same thing happen to others. If all input D3, D2, D1 and D0 equal to 1, load equal to 1, clock equal to 1, clear equal to 0, all output Q3, Q2, Q1 and Q0 equal to 1. As a result, the output Q3, Q2, Q1 and Q0 all equal to 1. Okay, for the next slide, clear equal to reset. If clear equal to 1, all output equal to 0. Even Even load equal to 1, all input equal to 1. So in simple terms, clear reset the register and load stores new data. So for the last picture, if load equal to 1, input D3, D2, D1, D0 equal to 1, clock equal to 1, clear equal to 0, output will be 1. But if previous value load equal to 1, load equal to 0, clock equal to 1, clear equal to 0, output remain 1 because mux select the all value.
Application in real CPU component. 2 to 4 decoder with enable memory chip selection. When an address bus drive A1, A0 decoder exactly one chip select line to choose which memory region or peripheral is active. Instruction decode stage. Decoding small opcode or micro operation into control signal. Output selection. Enable one of several input-output devices. 4-bit register with load and clear. General purpose register. Small with storage used by CPU instruction to hold operands and result. Pipeline register. Store stage output IF ID, IDEX, EXMEM between pipeline stage, usually synchronous and with careful timing constraint. Register file building block. Register array are built from multiple such single bit or single word registers with read, write control. Memory map buffer holds data to from peripheral devices. Challenges. In this project, designing the 2 to 4 decoder with an enable signal was challenging because it required precise logic expression to ensure that only one output was active at any time and that the enable function operated correctly. For the 4-bit register, using multiplexers and D flip-flop demanded careful control so that the register loaded new data only when the load signal was active and clear properly when needed. Debugging wiring and timing. Issue in LogiSim also require through testing to ensure the circuit behave as expected.
I simulated two main circuits. A 2 to 4 decoder with enable, which activates one of 4 outputs and is commonly used for selecting memory blocks, and a 4-bit register with load and clear, which stores a 4-bit value, updates on the clock edge, and uses load to write new data and clear to reset the outputs. The designs use basic logic gates like and NOT along with multiplexers and D flip-flops. These circuits are fundamental buildings blocks in CPU architecture, and through the simulations in LogiSim, I gained a better understanding of how control signal works and how data is stored and managed in digital system. That's all from us. Thank you.